In this video, we're going to be talking about combining like terms. Some definitions that we'll need to know for this lesson is the definition of the word term. A term is a number, a variable, or a product or quotient of numbers and variables that is either added or subtracted in an algebraic expression. In other words, each term that we can see will be separated by a plus or minus sign. I'll show you some of those variables here in a second. Terms. Our next definition that we're going to talk about is variable. A variable is a symbol, usually a letter, that represents a quantity that can change. An example of a variable would be x, or y, or z, or any combination of letters. A constant is a term in an algebraic expression that does not change. It does not have any variables. A constant, an example of that would be 2 or -5 or 1,000. Just a solo number, that's a constant. And another definition we need to know is coefficient. So the coefficient is a number that is multiplied by a variable. So for example, the 2 in front of the a, that 2 is the coefficient. Any number in front of a letter is called a coefficient. So what are like terms? A term that has the same variables or set of variables raised to the same power. So I have a little activity I wanted to show you really quick to kind of help you with that. These over here are terms. If we were to take any combination of these and add them or subtract them together, we would then start looking for like terms to combine those. They have to look exactly the same. So what I did is I color coordinated them. So I took this one, for example, 3xy squared. The 3 just tells you how many xy squareds you have. So I have 3 of them. So what I would look is I would look down the list and I would look for something that maybe has the same colors, since I'm color coordinating it on the right. Or if I'm pretty good at this, on the left, I would look for some that have the same exact combination of variables and exponents. So in this case, if I've already highlighted it on the left, but if you're looking for a combination of yellow and blue, here's the next combination of yellow and blue. Those, therefore, would be like terms. What I could do with those like terms is I could like add them together perhaps. So what that would look like would be like 3xy squared plus 9xy squared. Remember, these coefficients are telling you how many you have. I have 3 in this case, and I have 9 in this case. So how many grand total do you have? Well, you have 12 xy squareds. That's what combining like terms is really meaning. So as you kind of look at your letter combination as well as your exponent combination, if you want to color them and see what kind of combinations you can come up with, that would be okay. So what we're going to do is we're going to look for the one that matches -12x squared y. If it helps to see the colors, we're looking for a combination of x squared y, or green and red. So as I look down until I find I found it. Here's the combination of x squared y, or green and red. So those two would be like terms. So the dog matches the fish. If I were to do this again, just looking for a blue X, where would I find this? A solo blue X right here. So horse would match rabbit. If I'm just looking for a Y squared, if you're getting good at this, just look down the line and see if you can just find a regular old Y squared. Oh, it's right here. Or if I'm just looking for a solo yellow, there's my next solo yellow. So frog and cow would match. I'm going to ask, are you guys kind of catching on? If not, look at the screen and see what things would match together. But while you're doing that, I'm going to go ahead and go back to my combining like terms notes so we can practice. So we're asked to combine like terms, and remember, you can only combine terms that are being added or subtracted. So what we need to do is we need to perform the order of operations first, which would be PEMDAS, in order to simplify this so we know what terms we are adding or subtracting. So the P in PEMDAS means I need to take care of these parentheses first. When I look at those parentheses, nothing on the inside can be combined. So I cannot simplify negative 4 plus 7. I cannot simplify that 1 minus 3m because these are not like terms. So what I need to do then is I need to do, there are no exponents, so I'm done with that. But I want to do multiplication or division to simplify this. So I've got 7 times 1, which would be 7. Then I'm going to have 7 times negative 3, which is negative 21m. And that negative 4, whoops, it just stays right there. So now what I'll do is I'm going to look at adding and subtracting anything if I can as I go left to right. So when I read this going this way, are there any like terms that I can combine? Well, negative 4 and positive 7, they're like terms because they're constants. So negative 4 plus 7, that's 3. And then minus 21m. The 3 and the negative 21m cannot combine because of that variable right there. So if I were to say, okay, can we combine any other like terms? No, this would be as simplified as I can get. All right, so let's look at our next one. We're going to try to simplify using the order of operations. Taking care of my parentheses first, I'm going to try to see if I can combine 6 plus 7n. Because 6 and 7n are not like terms because of the n, we cannot combine anything. So I'm going to go ahead and leave it as 5n plus 3 times 6 plus 7n. So I've taken care of looking inside parentheses. There's no exponents to take care of. So next I'll do multiplication or division, whichever comes first, going left to right. So as I look at this problem, the first opportunity I can either multiply or divide is right here in these parentheses saying 3 times 6 and 3 times 7n. So I'll leave that 5n, negative 5n, and then as I distribute that 3 inside, I'll get a positive 18 plus 21n. Now when I look at my problem, I'm going to see if I can add or subtract anything going left to right. When I look left to right, there's a lot of plus signs, so I know I'm going to be adding something, hopefully, if there are like terms. This negative 5n says I have negative 5 n's hanging out. This 18 just says I've got 18, and this says I have 21 n's. Well, I do have like terms. My like terms happen to be this negative 5n and this 21n. So I can combine those. Negative 5n and positive 21n is going to be, I have no idea, 21, 20, 19, 18, 17, 16. Oof, so sorry. 16n, and then plus 18 would follow because it cannot combine with this 16 because they're unlike terms. It just sort of follows along. So right there is our simplified answer. All right, lastly, I'll go ahead and do this one. I need to do parentheses. I need to do PEMDAS. I'll look inside of the parentheses and see if I can simplify anything on the inside. So 6m minus 3n, because those are unlike terms, they have to stay. I have 1n and 4m. Those are unlike terms, so they have to stay as well. So I've looked at my parentheses. There are no exponents, so I can take care of multiplication or division, whichever comes first, left to right. in this case, we're just dealing with multiplication. So my first set going left to right would be negative 9 times 6 and negative 9 times 3. So negative 9 times 6m is going to be negative 54m. And negative 9 times negative 3 is a positive 27n. Now, there's more multiplication to happening here. I've got that 6 times 1n and 6 times 4m right here. So I'll go ahead and do that. So that would be 6n, and 6 times 4, that would be 24m. Now I've taken care of all of my multiplication and division, so now I'll take care of adding or subtracting. I want to look for things that have the same variable. So if it's helpful, if this is an m, I want to highlight all my m's. So if I've got negative 54 on one side and 24 on the far right side, if I were to combine those, that would create negative 30m. And I'm going to look at my n's now. I guess I'll do orange on those. This n and this n are like terms. So if I were to combine those, 27 plus 6n, that's going to be positive 33n. And since m and n are unlike terms, this is my final simplified answer. If you'll write down something that might have challenged you from this lesson, I'm going to check that and see how that looks. I also want you to do a I need to know. What is a must know for this lesson? I would like you guys to list about 3 things of what you need to know on this one. It could be something you already knew, but you need to know it as you live and continue on in math, or it could be something that you learned today. These practice problems, I'm going to post the answer key to Google Classroom so you can check your work.